Hello. I'm going to talk about um, a rather difficult subject. I'm going to talk about what is matter and what. Um, I'm not going to say that this is the view physicists have, but this is the, the in my best understanding what the physicists' view of matter is. So the way I comprehend physics and understand what physicists is saying is what I'm going to convey. So it's very important to understand that I'm not saying that this is a view of physicists. I'm saying this is my understanding of physics. Okay, that's the first point. And I want to go through a historical view and then the modern view. And in my opinion, it could be segmented into the view of matter can be segmented into three views. And the first one is pre 20th century. The next one is early 20th century, and the last one, which is the current view, is late 20th century. The pre 20th century is primarily dominated by Greek thinking. The early thinking about matters is predominantly influenced by quantum mechanics, and the late 20th century is predominated by thinking from what is called quantum field theory. So and each of these has its own paradigm, how we look at matter. And if we look at the first one, the Greek view, the Greek, they were, how should I say, they were thinking people. They didn't do that much experiment. They liked to solve things with pure thinking. And thinking told Greeks that there has to be some smallest element. So, and it's natural, actually, if you think about it, that in everyday life you grind, things breaks, they go apart. And you could grind down things to smaller and smaller pieces into a powder. And if you see this process, it's natural to ask yourself how small pieces can we make. And the Greeks, they were quite clever because, so let's say there is some piece here. And that could be divided in planes like this. You cut it up along these axes. So you have a cube that could be split up like this. In smaller pieces. And the question is, of course, like how many times can you do this? How many times can you divide something? So if you take this thing here, divide it in half, then half, then half, then half, then half, then half, then half. How, and if we magnify this thing here, this area here, which looks like that now, we could continue and we could magnify it again. We have this line here and continue, break it down. Then the question is, how far can we go? How many times can we do this? And the Greeks, I guess they understood the concept of finite small things, because the thing is here that if you continue divide something, let's say you have 1 and then you divide it 3 times, 4 times, blah blah blah, 1,000,000 times, and so on, to like any number. And when that number gets large enough, and with large enough I mean when it gets infinite many times, so when you have 1 through infinity, then this will be equal to 0. I have posted a video which is called Odd Numbers, where I've shown that 1 is equal 0.999 blah blah blah. The conclusion I made from that thing is that if these two are numbers on a scale, and this is number 1 here and this is number 999 here, the distance when we go to infinity, many nines, the distance between those two numbers is not a very very tiny small number. It's actually 0. That distance there, they're located at the same spot. And if you divide something infinitely many times, you will come to a point where you where the distance when you divide things is 0. So that means that thing you divided up has a size of 0. And 0, that's just another way to say nothing. That's just another way to say nothing. So if you allow things to be infinitely small, then you end up with nothing. And then the question is, and this is how I think the Greek was using logic, that how could you get something from nothing? And their answer to this was probably you can't. So they probably reasoned, I don't know how they reasoned, but this is my guess. They probably reasoned that if you have this chain where you divide things, at some point that chain is going to break. And then you have a smallest element which you can't break up anymore. And they called this atom. And in Greek, that basically means you can't divide it anymore. That's what atom means, undividable. So they said that they postulated there must be some smallest element that is undividable. Okay, so what this smallest element is, this is, they said matter was made of this smallest element. So the idea here now is, I don't know if it's been expressed by the Greek or something, but this is what I'm going to express now. If if you think that the universe is made up of stuff, some small buildings block, necessarily not squares, maybe they are, or not cubes, but maybe they are cylinders or something, I don't know. But small, there are very, very small, tiny elements that are built up of. And if you think about the understanding the Greeks had of that world and apply these things here, we could say that there is small things that exist in a space. So you have like objects here. These small things exist in a space, but the thing here is like these things are not connected with the space. It's independent objects of themselves, because you could think about that object without thinking about it being in a space. So you could say that space didn't exist, but what exists was object, and these objects has distances between each other, and that distance between the objects they called space. But space itself actually didn't exist. What existed was distances between objects. So you have stuff that fills the world, and then you have space, which is the distance between these things. That's yeah. I think I've stopped now when it comes to the way the pre-19th century view is.